All right, let's dive in. Today we're taking a closer look at glaciers.
Yeah.
You've given us this incredible presentation, and I have to say, even just looking at the pictures is amazing.
Yeah.
But we're going to go beyond just the pretty pictures, right? And really unpack how these massive glaciers form, um, what the different types are, how they move, and how they actually shape the landscape around them. We'll even get into some of the really interesting features they leave behind.
Right. Yeah, those are always fun to look at. You've got your big moraines
Yeah, the moraine.
and even kettle lakes. Those are always really pretty.
Yeah, absolutely. So those pictures are in the presentation you gave us for anybody listening.
Oh, right.
But yeah, we'll get into all of that. But first, I think it's important to start with the basics. What exactly is a glacier?
Well, the presentation defines it as a big mass of ice formed from snow. But, it's not just any ice.
Right.
Over time, the snow gets all compressed and recrystallizes, and it ends up being this super dense ice.
Okay, so it's not like the ice cubes in my freezer.
Exactly.
This is a whole different beast.
This whole different animal, and, because of all that weight, it starts to flow outwards and downwards because of gravity.
So it's like a really, really slow-moving river,
Yeah, you can think of it that way.
but made of ice, which is wild. And this movement, is it just like sliding downhill? Or is there more to it?
Well, there's more to it for sure. There's a lot happening beneath the surface. So melting and refreezing at the base of the glacier, that definitely plays a role. But then you've also got something called internal deformation.
Internal deformation. Okay, now you're getting a little technical on me here.
Well, imagine like a deck of cards,
Mhm.
okay?
Yeah.
And you're spreading it out under pressure. So the cards kind of slide past each other.
I got you. Okay.
The ice crystals within the glacier, they actually behave kind of similar to that, which contributes to the movement.
Wow, that's incredible. So it's not just one thing. It's like this combination of factors all working together. You've got the sliding, the melting and refreezing, and even the ice crystals themselves are shifting. And that's what allows these massive glaciers to move.
It's a lot more complicated than people might think.
It really is. And speaking of massive, the presentation talks about different types of glaciers.
Yeah.
So let's break those down a little bit.
Sure.
What are the main types?
So first off, you've got what are called continental glaciers. These are the really enormous ones.
Okay.
They cover massive areas of land, the kind you find in Antarctica and Greenland. Those ice sheets can be thousands of meters thick.
Thousands of meters.
Yeah. They have a huge impact on the global climate and sea levels, obviously.
Yeah, I can only imagine. And they flow outwards from the center just because of their sheer weight, right?
Exactly. It's just the immense pressure causes them to spread out.
It's amazing how something so big can move at all.
It's mind-boggling, really. And then you've got the other main type, valley glaciers. And as the name implies, these are the ones that are found in valleys. Okay. So they're confined to those mountain ranges. And I'm sure you've seen pictures, those stunning photos of glaciers winding their way down between those peaks.
Yeah, absolutely. They carve out those U-shaped valleys
That's exactly right.
that you see in a lot of mountains.
They
It's
do.
incredible.
It's like nature's way of sculpting the landscape over time.
They're really powerful forces shaping the earth in such a dramatic way. And this brings up a really important point. These landforms, whether they're created by continental or valley glaciers, they're like fingerprints, right?
Exactly.
They tell us a story. They reveal this history of ice activity.
Yeah, like detectives looking for clues.
Exactly. So let's dive into those clues a bit. What are some of the specific formations that glaciers create?
Well, the presentation talks about two main categories, erosional landforms and depositional landforms. Let's start with erosional. It's basically what the glacier carves out, what it takes away.
Okay.
So imagine a glacier's like this giant rasp just grinding away at the landscape.
I can picture that. Okay.
It creates things like cirques, those bowl-shaped depressions.
Mhm.
High up in the mountains, sometimes you'll find a smaller glacier nestled inside one of those.
Yeah, wow.
And then you have horns, these sharp, pointy peaks that are formed when a glacier erodes several sides of a mountain.
Okay.
Think about the Matterhorn.
Oh,
It's
yeah.
a classic example.
That's a good one. Yeah.
So those are some pretty impressive sculpting skills, on the part of the glacier.
Because they really are.
And then there are arêtes, those narrow ridges that you get between glacial valleys.
Mm-hmm.
And then, of course, you have the U-shaped valleys themselves.
Right.
It's amazing to think about just the sheer power of ice to create all of these dramatic landscapes that we see.
It's humbling, really, when you think about how powerful these forces of nature are. It's incredible. But it's not just about what they carve away, right? It's also about what they leave behind.
Exactly. That's a really important point.
And that's where we get to the depositional landforms.
Right. Those are the features that are formed from the debris that the glacier carries and deposits.
So like a sculptor leaving behind their shavings and dust.
Yeah, you could think of it that way. So one of the most common features you'll see are moraines. Basically, it's just a ridge
Okay.
of rock, gravel, sand, clay, all kinds of stuff that the glacier has kind of pushed and piled up.
Okay.
And you find them at the edges of glaciers, or where the glacier used to be. And they come in a few different varieties. You've got lateral moraines, which run along the sides of the glacier.
Okay.
Medial moraines, which form in the middle, where two glaciers have kind of merged together.
Okay.
And then terminal moraines, which mark the furthest point that the glacier reached.
Yeah.
So they're kind of like breadcrumbs, you know?
Oh, they're like tracing the glacier's path.
Exactly.
I like that. That's a really good analogy.
They tell us about the journey that the glacier took. So, moraines are definitely one of the key depositional landforms. But then you've got some other really interesting ones.
Like what?
Well, there are drumlins, those smooth, kind of elongated hills that are made of glacial till.
I've seen pictures of those. They almost look like a giant's footsteps or something.
Yeah, they kind of have that streamlined shape,
Right, right.
and their shape actually indicates which direction the glacier was flowing in.
Oh, that's cool. So they're like little arrows pointing the way.
Exactly. And you often find them in groups, like a whole bunch of them together. It's really fascinating.
That's so cool. What else do we have?
Okay, then there are eskers. These are long, winding ridges of sand and gravel,
Okay.
and they form from meltwater streams that flow underneath the glacier.
Underneath. Wow.
Yeah, so as the water flows, it deposits all this sediment, and eventually it creates these ridges.
That's amazing.
It's like they're the fossil rivers of glaciers, kind of tracing out where the meltwater used to flow.
I love that. It's like they leave behind these secret paths.
Exactly.
So cool. And of course, we can't forget about kettle lakes.
Oh, yeah.
Those are always beautiful to see in pictures. How do those form?
So as a glacier retreats, it often leaves behind big chunks of ice. And when those chunks finally melt, they leave behind these depressions in the ground.
Oh.
And then those depressions fill up with water,
Oh,
and you get a kettle lake.
that's incredible. So they're kind of like a reminder of where the glacier used to be.
Exactly. And you often see them occurring in groups.
Okay.
So you might have a whole cluster of kettle lakes all dotting the landscape. So, when you look at all these depositional landforms, it's like they're pieces of a puzzle.
Mm.
They come together to tell us this incredible story about a glacier's life, its movements, and even the climate conditions that existed when it was active. It's like a window into the past.
It really is like a time capsule, preserving all these secrets about Earth's history. That's fantastic. But glaciers aren't just relics of the past, right? They're still actively shaping the planet today. And unfortunately, the presentation makes it clear that they're facing some pretty serious challenges right now.
Right. That's the other side of the coin.
Yeah,
And it's definitely something we need to talk about.
absolutely. One of the biggest challenges is glacial retreat. And I think a lot of people know that glaciers are melting at an alarming rate globally.
Yeah. Unfortunately, it's happening much faster than we'd like to see. And the main driver behind this, it's climate change. Rising temperatures are playing a major role. It's not as simple as just saying warmer weather equals melting glaciers, though.
Right, the presentation goes into a lot more detail about why this is happening. And there are some pretty complex factors at play, right?
Definitely. Like one of the things they talk about is albedo.
Albedo. Okay, I'm not familiar with that term.
So basically, it's how reflective something is.
Huh?
And ice and snow, they're very reflective. So they bounce a lot of sunlight back into space,
Oh,
which helps to keep the planet cool.
so it's like a natural cooling system.
Exactly. But when the glaciers melt, they expose the darker surfaces underneath, like rock and soil.
Right.
And those darker surfaces, they absorb more heat.
So it's like a vicious cycle.
It is. Less ice means more heat absorbed, which leads to even more melting, and so on. It's a positive feedback loop.
And that makes the problem of glacial retreat even more worrying, right?
Yeah, for sure.
Because it's not just a linear process, it's accelerating.
Exactly. And the consequences of all this melting are really far-reaching. One of the most obvious ones is rising sea levels.
Yeah, I think that's something that most people are aware of. Coastal communities are already dealing with the impacts of rising seas, and it's only going to get worse as these glaciers continue to melt.
It's a global problem, with huge implications. And it's not just coastal flooding either.
Right. What else?
Well, glacial meltwater is also a really important source of fresh water.
Oh, yeah, especially in mountainous regions.
Right, exactly. So people who rely on that water, for drinking, for irrigation, even for hydropower,
Right, right.
they're going to face some real challenges as the glaciers shrink. It highlights just how interconnected everything is on this planet.
Yeah, you can't just change one thing without it affecting everything else. It's a delicate balance. And when that balance is disrupted, it can have really serious consequences. What are some of the things that we can do to address this?
Well, the presentation actually goes into that in some detail,
Okay, good.
and they stress that it's going to require a multifaceted approach. It's not just about reducing our greenhouse gas emissions, although obviously that's really important.
Right, we have to tackle the root cause of the problem. But even if we do that, there's still going to be some level of change that we have to adapt to.
That's right. And the presentation talks about developing more sustainable water management strategies, figuring out how to protect coastal communities from rising seas, and even exploring some, maybe even some more controversial options like geoengineering.
Okay, now those are some big ideas.
They are, yeah.
And I think it speaks to the urgency of the situation that we're even considering these kinds of things. But something that really struck me when I was going through the presentation
Yeah.
was how much emphasis they put on understanding the past in order to prepare for the future. They talked about paleoclimatology,
Oh, yeah.
which is essentially studying past climates, which sounds fascinating.
It is. It is. So, by looking at things like ice cores and sediment layers, tree rings even, scientists can kind of reconstruct Earth's climate history and see how glaciers have responded to changes in the past.
Wow, so it's like having a time machine for climate change. That's amazing.
Yeah, it really is. And that knowledge is super valuable because it can help us predict how glaciers might behave in the future under different climate change scenarios.
So it's not just about looking back, it's about using that information to inform our actions moving forward.
Right. It can help us anticipate potential problems and start coming up with adaptation strategies.
Yeah.
There's that old saying, those who cannot remember the past are condemned to repeat it.
Right. But in this case, understanding the past could be the key to creating a more sustainable future. And something else that the presentation did really well, I think,
What's that?
was bring in the human element. It wasn't just about the science, it was about the people who are being affected by this.
Oh, yeah. It features stories from people all over the world who are already feeling the impacts of glacial retreat.
Right.
From farmers who are struggling with dwindling water supplies
Mm.
to indigenous communities whose cultural traditions are tied to glaciers.
Mm.
It really puts a human face on this issue.
Yeah, it's easy to get caught up in the big picture, the science and the data, but ultimately, this is about people's lives and livelihoods, and it's happening right now.
Exactly.
It's not some far-off problem.
It's not just happening in the Arctic, it's everywhere.
It really underscores the urgency of the situation. But, even with all the challenges, the presentation doesn't leave us feeling totally hopeless.
Right, it ends on a message of hope.
It does. It really emphasizes that even small actions can make a difference.
Absolutely. Reducing our own carbon footprint,
Wow.
supporting policies that address climate change,
Right.
speaking up about the importance of protecting these incredible glaciers.
Every little bit helps.
It does.
It's a reminder that we all have a role to play. Going through this deep dive, it's been really eye-opening for me. I've always been fascinated by glaciers, but now I feel this sense of awe at their power and beauty, but also a sense of concern for their future and this feeling of responsibility to do what I can to help.
Yeah, I know what you mean. It's hard not to feel that way after learning about all this.
What really struck me was how much the presentation highlighted the connections between glaciers, climate, and human societies. It's all intertwined.
It really is. And that's something that we need to keep in mind as we move forward.
It's like the presentation saying, hey, look, everything's connected. And it does such a good job of bringing all these different pieces together, like those amazing landforms we talked about.
Right. The moraines, the drumlins, the eskers, even the kettle lakes.
It's incredible how much we can learn about a glacier just by looking at what it leaves behind.
It's like a story written in the earth itself.
I love that. And each landform tells us something different.
Yeah. Like its size, how it moved, even what the climate was like way back then.
It's mind-blowing, and all those clues are becoming even more important now as we try to figure out how glaciers are responding to climate change today.
Exactly. By looking at those old glacial cycles, we can kind of get a glimpse into the future.
See what might happen if things keep going the way they are.
See how much they might retreat, what the impacts might be. And the presentation makes a really good point about all this. It's not just about science and data.
Right.
It's about people.
Yeah.
Real people all over the world who are already dealing with the effects of glaciers melting.
People who depend on that glacial meltwater for their survival.
Right, exactly. For drinking water, for their crops, even for power.
And then you've got the coastal communities that are facing rising sea levels. The human side of this is just as important as the science. It's what makes it real.
Absolutely.
Hmm.
It's a reminder that we need to think about people just as much as we think about data.
Find solutions that work for both the planet and its people. You know, this whole deep dive, it's been so insightful. I've always been fascinated by glaciers, but now I feel like I have this whole new appreciation for them.
Yeah, me too. They're just incredible forces of nature.
Powerful and beautiful and so important for our world. And I definitely feel a stronger sense of responsibility now to do what I can to protect them. The presentation doesn't sugarcoat things. It shows us the challenges.
Right, it's not all sunshine and rainbows.
But it also gives us hope.
It reminds us that we can make a difference. Even small actions can add up.
Reducing our carbon footprint, supporting the right policies, making our voices heard, it all matters.
Every little bit counts. So as you go out there and keep learning and exploring, remember the glaciers. They're a reminder of how amazing our planet is.
But also how fragile it is.
And how important it is to take care of it.
Couldn't have said it better myself.
Yeah.
Well, that's about it for our deep dive into glaciers. Thanks for joining us on this chilling adventure. And remember, the future of these icy giants and our planet is in our hands.